Okay, so in this tutorial, we're going to learn how to write an inverse for this function. So I have this function, 2x plus 4 equals 3. We're going to use what we've learned before by creating the inverse operations diagram. Okay, so this is from first semester. I'm going to start with x, and following PEMDAS, I want to see what happens to x first in this function. So here, there's actually invisible parentheses in the numerator. So I want to do what's first in the parentheses. It's being multiplied by 2 and then added by 4. So I have times 2, add 4. After I add 4, I divide this quantity by 3. Okay, so divide by 3. And that's going to give me f of x, okay, which is the output. So we went from input to output. For the inverse, we're going to go backwards, and we're going to say, here's my input. The opposite of divide by 3 is multiply by 3, subtract by 4, and dividing by 2. And that's going to get me the output for the inverse. So to recreate all of this, I'm going to use this notation. It's an f with a little -1 on the top as a superscript. That is not an exponent. It's just how we say inverse. Okay, so let's build our function. So here is saying x is being multiplied by 3. And so we can write that as 3x, 3 times x. And then that quantity is being subtracted by 4. And then dividing by 2. Now we're saying this whole quantity is being divided by 2, not just the 3x or the 4. The whole thing is being divided by 2. Okay. So that is my inverse. Okay, so one more time, this little -1 is not an exponent. This means inverse. And the way you say this, don't say f -1. This is f inverse of x, if there's an x in it. So f inverse of x. Or you can say inverse f of x. Okay, so to recap, we did the inverse operations diagram. We went forward, and then we went backwards to see the inverse operations. And then we rewrote the inverse as its own function.